Hello class, this is Mrs. Zappia with Eureka Math Lesson 7, Unit Rate as the Constant of Proportionality. Our essential question for this lesson is, what is another name for the constant that relates the measure of two quantities? In example 1, the National Forest deer population in danger. Wildlife conservationists are concerned that the deer population might not be constant across the national forest. Let's look at that word, constant. The scientists found that there are 144 deer in a 16 square mile area in the forest. In another part of the forest, the conservation counted 117 deer in a 13 square mile area. Yet a third conservation counted 216 deer in a 24 square mile plot of the forest. Do the conservationists need to be worried? Why does it matter if the deer population is not constant in a certain area of the national forest? Well, that could affect the food supply for the deer. Some areas might be overpopulated, and if there are too many, it could damage the land. For the first question, what is the population density of the deer per square mile? What they want us to find there is the unit rate. Per square mile means the quantity of deer for 1 square mile. So we want to set up our table. Remember that the first line of a horizontal table is the x value, and the second quantity in the table is the y value. So the square miles is the x, so we'll take our first pair of 144 deer in 16 square miles. That's 16 square miles and 144 deer. The second ordered pair, 13 square miles and 117, and 24 square miles and 216 deer. So we filled in our table for the population. The next question, the population density of deer per square mile. So we want to take our number of deer. Remember that when you're finding the constant, it's y divided by x, where y is the number of deer divided by the square miles. So we'll take an ordered pair, and we'll just use the first ordered pair, 144 divided by 16. And that answer is 9. Then we do the same with the second ordered pair, 117 divided by 13, and the answer is also 9. And our third pair, 216 divided by 24, and the answer is 9. So the population density of deer per square mile is 9. And that means that there are 9 deer, approximately, in 1 square mile of area. So the constant of proportionality, that is the same thing as the constant. So the population density is 9. The meaning of the constant of proportionality in this problem, it's the number of deer per square mile. Remember that the constant of proportionality is the same thing as the unit rate. So K is also called the unit rate, also called the constant. Use the unit rate of the deer per square mile to determine how many deer there are for every 207 square miles. So we have an equation where y equals kx, where k is the unit rate, and we know that that number is 9, and x is the number of miles, which we are told to use 207, and then y is the deer. So to find the value for y, you take 9 deer per square mile times 207 miles, and that gives you your answer, 1,863. So there are 1,863 deer in 207 square miles. Let's add that to the table. Going up in our table, I'm going to erase this so that we have a little bit of room. And just add that to the table. So we've got 207 square miles, 1,863 deer. Continuing, use the unit rate to determine the number of square miles in which you would find 486 deer. So let's go ahead and add 486 to the table and then solve the problem. 486 is the number of deer, so you want to make sure and put that in the right part of the table. The deer is the y value, 486. And we need to figure out how many square miles will be required for that. So let's look at the pattern of if you know the y value, how do you determine the x value? And if you were going down from 16 to 144, you would multiply by 9. Since you're going up, you need to divide by 9, which is the unit rate. So we're going to divide by 9 to find the unit rate. Go ahead and do that on your calculator now to calculate the answer. And 54 is the correct answer. So there will be 54 square miles for 486 deer. Summarizing this problem, we were looking for the number of deer per square mile. So the number of square miles could be defined as x, the number of deer could be defined as y. The unit rate of deer per square mile is 144 divided by 16, which is 9. This is called the constant of proportionality, and it is 9. The meaning in the context of this problem is that there are 9 deer for every 1 square mile of forest. So let's go over some vocabulary on the next page. A constant is a unique number. So a constant is just a number, like 4, 4.5. It can be a whole number, it could be a decimal. A variable is a letter that represents a number, such as x, y, or k, are some examples. A unit rate is the value of the ratio. So when you divide y by x, it gives you one number, and that is the value of the ratio, that is the unit rate. It's the number of units of one quantity per 1 unit of the second quantity, such as miles per hour or words per minute. A constant of proportionality. This is just another name for unit rate, or another name for the constant. It's the multiplicative relationship between the quantities. So the unit rate is the constant of proportionality, and it is also called the variable k, or the constant. In example 2, you need what? Brandon came home from school and informed his mother that he had volunteered to make cookies for his entire grade level. He needs 3 cookies for each of the 96 students in 7th grade. Unfortunately, he needs the cookies the very next day. Brandon and his mother determined that they can fit 36 cookies on 2 cookie sheets. Create a table that shows the data for the number of sheets needed for the number of total cookies baked. Well, the first thing that you will want to determine is how many cookies do you need to bake altogether. So if you have 96 students and they are getting 3 cookies each, take a minute, pause the video, and find out how many cookies they will need altogether. If you found out that they will need 96 students times 3 cookies each is 288 cookies. So the answer is 288 cookies altogether. Next, create a table that shows the data. So let's look at our table. If this is data that's given to us, it says in the data that we have 36 cookies can fit on 2 cookie sheets. So the number of cookies you can bake is dependent on how many cookie sheets you have. So cookies is the dependent variable. So then, well, what if you wanted to have 4 cookie sheets? Then how many cookies would you be able to have on the cookie sheets? So you want to know, well, how many cookies could you put on 1 cookie sheet? So 36 divided by 2 will answer that question. 36 cookies divided by 2 sheets equals 18 cookies per sheet. Then, if you know how many cookies you can put on 1 sheet, you can figure out how many cookies to put on all 4 sheets. So if you have 4 sheets and they have 18 cookies each, pause the video and find out how many cookies that is altogether. So you multiply 4 times 18 and you get 72 cookies. Next, let's find out how many cookies you can make on 10 cookie sheets. So 10 cookie sheets times 18 cookies is 180. And we know that we need 288 cookies, so we're going to keep going. And let's see how many cookies we can make with 16 sheets. So 16 times 18, go ahead and calculate that. And the answer is 288 cookies. So now we know that we need 288 cookies. We also know that we need 16 sheets of cookies to make that many cookies. And the question that next is asking, is the number of cookies proportional to the number of cookie sheets used in baking? So finding the number of cookies per sheet, we did that and the answer was 18. Since it is the same pair for x, y, then the cookies is proportional to the cookie sheet. I know that because 36 divided by 2 is 18. 72 divided by 4 is 18. 180 divided by 10 is 18. And 288 divided by 16 is 18. And since I got 18 cookies per sheet for all of the pairs, then this is a proportional relationship. Because it doesn't matter how many cookie sheets you have, it will always have 18 cookies on it. So the unit rate for y divided by x, you find that by looking at a pair of the numbers. So we have 36 cookies over 2 sheets, and 36 divided by 2 is 18. So remember, it's y divided by x to find your unit rate. The constant of proportionality, that's the same thing as the unit rate, which is 18. Explain the meaning of the constant of proportionality in this problem. Well, remember that the constant of proportionality is the same thing as the unit rate, so it's how many cookies per sheet. There are 18 cookies per sheet. It takes 2 hours to bake 8 sheets of cookies. If Brandon and his mother begin baking at 4 p.m., when will we finish baking the cookies? So 2 hours to bake 8 sheets, and we know that we need 16 sheets. So we have to figure out how long would that take. Well, look at the multiplier. We need twice as many sheets, so it will take twice as long. So instead of 2 hours, it will take twice as long, and the answer is 4 hours. So it says that they're starting at 4 p.m. and you need to add to that the 4 hours to make the cookies. So you know that the answer will be 4 plus 4 is 8, and they will finish at 8 p.m. Example 3, French class cooking. Suzette and Margot want to prepare crepes for all of the students in their French class. A recipe makes 20 crepes with a certain amount of flour, milk, and 2 eggs. So first let's explain what a crepe is. A crepe is a very thin pancake. The girls already know that they have plenty of flour and milk to make 50 crepes, but they need to determine the number of eggs they will need for the recipe because they are not sure if they have enough. So we know that 2 eggs will make 20 crepes. Considering the amount of eggs necessary to make the crepes, what is the constant of proportionality? So we know that it takes 2 eggs to make 20 crepes. And we want to know how many eggs it will take to make 10 crepes. Well, if you look, you're going to be making half the amount, and so this number would be half the amount as well. Another way to think about it is y divided by x. So 2 divided by 20. 2 divided by 20 is 1/10. So that will take 1 egg. And so the constant of proportionality is 1. The constant of proportionality in this case means that 1 egg is needed to make 10 crepes. What does the constant of proportionality mean in this problem? 1 egg for 10 crepes. So this is set up a little bit differently than we've done some of the other problems in terms of the numerator and the denominator. Normally, when you're talking about the constant of proportionality, we would have the second quantity being what we want 1 of. So you will need 1 egg for 10 crepes. But they're asking, in this case, about the eggs. So how many eggs are needed to make 50 crepes? Well, if 1 egg makes 10 crepes and we need 50, we need to multiply our recipe by 5. And that means you'll need 5 times as many eggs, so you will need 5 eggs. In closing, let's just talk about this and not write it down. I would like you to write your summary in class tomorrow at the beginning of class. But what we learned in this lesson is another name for the constant, and that's called the constant of proportionality. And the constant of proportionality is the unit rate, found by dividing y divided by x, and it is called k. It is the constant number. It is the multiplier that works every time. And that concludes our lesson 7.